Next, we have Shoaib Merchant, a software engineering architect with over a decade of experience across software, hardware, and cloud technologies. As the founder of Mecha Systems, he'll be introducing us to Mecha, an open hardware and software company, and their first product, the Mecha Comet, a programmable handheld computer. In this talk, he will explore the challenges of closed hardware ecosystems and the possibilities of building accessible computing for everyone. This talk will also feature demos, use cases, and what you can build with Mecha's platform. So join me to welcome Shoaib Merchant.
Good afternoon, everyone. Nice to be here. Thanks for making it to the talk. Voice is clear, fine? Okay. Yeah, so my name is Shoaib. I'm the founder of Mecha Systems. My talk is about building computing in the real world. We all have been familiarized with building on the cloud, building on mobile phones, right? But how do we bring computing out in the real world, right? So that's going to be our talk. And this also talks about how our journey in building Mecha has been, how did we start and how did we get here. So I'm from Baroda, Gujarat. We have been recently infamous for the number of crocodiles in the city. I don't know how many of you have seen that. It is true. It is not, for once, it is not fake news. But yeah, we are from Baroda, Gujarat. Gujarat, as such, is slowly embracing electronics development and hardware, right? Gandhinagar and Ahmedabad, if not many of you would know, is a big electronics hub in India. There's a lot of engineering and custom designing that happens. So we are rightly placed in the region. I've done my bachelor's in technology from VIT in 2014. I've spent 10 years in leading a consulting firm in working across different sectors. The sectors were pharmaceuticals, analytics. So for me, I've been an engineer all my life. I like to build stuff. I like to be thrown challenges at, and at any opportunity that I can get to widen my horizon, I'm there to take it. Yeah, now, before we start with what Mecha is and what do you mean by building computing in the real world, I'll talk about how did we get to this. So sometime during COVID, we were working on a digitalization project for Siemens India. We were supposed to, actually we deployed a system which had a cloud equivalent and it required computing on the edge, which means we had to deploy computing machines on site, on their factory floors, right, that could work with their cloud backends. Now, at that time, we used to joke around in the team that it is so much easier to deploy on AWS or any cloud to a data center that we have never seen and we will never see in our own lives, right? And compared to that, deploying to a hardware right in front of us is so difficult. When we had this problem, we did the next logical thing. We started with Raspberry Pi, and then we slowly kept iterating. We added up, so the customer kept requesting us for more integrated capabilities, right? First, they wanted us a battery. So we literally opened up a power bank, took the battery out of it, took the battery management system from it, and put it inside a 3D printed contraption. You can see the 3D printed contraption right here on the screen. I still call it a contraption because for the life of me, I cannot call it as a proper device. And this kept going on. We kept iterating. The customer then next came up and said, okay, we want to see a battery percentage next to it, right? And when that happened, we found another power bank which had a battery percentage on it. We again opened it up, we took it up, put it inside our 3D printed assembly, and then delivered it to the customer. So this kept going, and then eventually we started seeing that, okay, why do we not have a programmable computer? And the closest thing that we have to a handheld computer is something that is right in front of our, like right in our pockets, right? That's our smartphone, right? But we know how the ecosystem around the smartphone is. I'll just talk about that. So you can see, I'm just sitting right there and doing the installation. Most of us are wearing masks because it was a very, during COVID, during peak COVID, the factory had the production stuck. We were requested by Siemens India head to come to Mumbai and do the installation for them. And during this time, we started talking about this idea that why do we not have a programmable hardware that is more accessible, that is more integrated, right, and something that can be used to deploy applications in the real world. So we started our journey back in 21 with this. We started doing some initial industrial design. You can see how the initial design evolved. Originally, we started with just a couple of USB ports. We started with a battery and started placing them in an assembly, and then kept evolving till we reached into a handheld form factor. Now, this eventually led into evolution of Mecha. The thought process of building a programmable computer landed up into looking into a bigger problem on how hardware can be improved today. Some of the things that we have understood in the hardware industry today here is that in the last 10 to 15 years, we have seen cloud computing grow and evolve, right? I'm sure a lot of you would know that initially when Facebook started, cloud computing was not as evolved as it is today. And every university required a separate blade in a data center, and somebody literally had to sit inside a data center ensuring all the blades work fine, right? So every time they wanted to open up for a new university, they would have to install a new blade in the data center. Now, challenges in the hardware industry today, right? The hardware that is readily available with us are basically either Apple iPhones or Android devices. Now, they are all locked ecosystems built for consumers, right? But as developers, we have started missing out, right? If we go back and talk about the early 90s or even the 80s, when computing was still not capitalized, it was not something that was available for everyone, right? It was restricted to engineers and developers and people like us to play around with. That's when in the 60s, 70s, that's when the Steve Jobs and the Gates of the world started popping up, because these computers were not locked ecosystems, right? They were open to extend, they were open to build, right? And the challenges today were not existent. Now, they work fine for a consumer medium, right? But they put us a bit backwards in terms of computing, right? Like today's young generations, now they see computers as iPads, right? Whereas in my time, it was a desktop cabinet that was always open and always something that was accessible right under, like with our hands. And I used to have my parents complaining that why is the cabinet never closed, right? So this is something that we have started missing out, and we would like Mecha to help bring that part back. One of the very common examples that I have used in these discussions is that I have an iPad mini lying around in my home, right? I paid full price for the iPad mini around 10 years back. It is still a good hardware, right? It's a good display. It still has a battery. It has a good touch, everything, right? But it's now a locked device for me, right? I cannot open Safari. Most of the SSL certificates, the root CAs are expired. App stores will tell me that this OS is not supported anymore, right? And that's it. It's just a lying piece of waste for me in the house now. Either I have to dispose it, but what good does it do to the world, right? And if in hands of people like you, we could build something on it, you could do a self-hosted home server running on it, right? So, but then that's how the industry has become, right? And that's why I call it capitalization of the computing industry, right? And we are all parts of it, right? We are expected to pay full price for hardware that is essentially a subscription, right? So with Mecha, we are trying to change this. We want to build computing hardware that is available for you, and you have its true ownership, right? You decide what part of it do you want to change, what part do you want to control, right? From the bootloader to the kernel to the root FS to the application layer, it is something that you truly are capable in working towards. And compared to a locked ecosystem, this is an unlocked ecosystem. So our job at Mecha is to not add barriers, but to break those barriers. So with this, I'm happy to share our first hardware. I think the screen resolution is not meeting up correctly, but it's a handheld computer. We call it the Mecha Comet. I'll quickly run a product video for it. So this entire board is designed in-house. We have been working at this in the past 2.5 years. We have had multiple revisions. The revision that you see today is the revision 4th. There are 40 pogo pins available, which you can extend for custom functionality. You can go ahead and build your own PCBs or use any of our open source extensions. From the CAD files to the STLs and the PCB sample designs, all of them will be available as open. You can download it, you can build your own, you can use services like Robu or JLC PCB and get your PCBs also printed, or you could use some of our already available extensions. I'll just come to that. Quickly summarize the specs. So we have a 1.8 gigahertz ARM processor. It is also running dual band Wi-Fi and Bluetooth 5.0. We have a PCI 2.0 slot on the device. We may be the only device in the handheld form factor that has a PCI slot directly. There's a 32 GB eMMC on board. There's a gigabit Ethernet. We have a crypto store. So essentially, if you need to privately store your private keys or AES keys or your encryption keys, you can use the store. All of the hardware that you see available in the device is accessible through open source SDKs we have built in Rust. They are available through gRPC, so we are not limiting you on a particular language or an SDK, right? You are free to build in the tools you already know. If you know Node.js, you can build in Node.js. If you know Rust, you can go ahead in Rust, Golang. We will not really limit you on what applications and in what way do you want to build. Also, the SoC is by NXP. We are sharing the SoC with the Remarkable 2, which is the e-paper, right? So it's a proven SoC, and compared to other system-on-chip manufacturers, it is well documented, and even the board support packages and the Linux kernel versions are all open source and openly documented and maintained. Okay, so if we talk about the firmware, the device is running U-boot. We are running 23.04, the version. Again, the U-boot is open source. The kernel, we are running the Linux kernel 6.1. Our distro is based on Debian 12, which means anything that works on your Ubuntu or your Debian-based machines would work out of the box. So you get access to 60,000 pre-compiled packages maintained by the Debian maintainers, and you are free to install additional packages as you need. Our shell is designed in-house. We have built a Wayland shell, something similar to FOSS. I think sometime last year in IndiaFOSS, FOSS was also presented as one of the talks or workshops. So we have our own Wayland power shell called Mechanix GUI. This is built in Rust. In fact, to be able to build this UI shell, we had to write our own UI framework because we were exhausted by all the UI frameworks available today in Rust, which would not really let us control on a lower level than your GUI applications. So most of you may not be aware, but all the GUI applications that you use are rendered by a compositor, and all your applications, they have some kind of a protocol communication that happens between the compositor which is drawing the screen at all times. It is drawing at the refresh rate. So in Linux, the new compositor communication protocol or the display server protocol is Wayland. So our GUI shell implements Wayland entirely, and we have built a UI framework that does canvas-based rendering. And like I said, everything on the device is free and open source software, so you are free to go download our kernel versions. You can modify our flash image, you can recompile them, you can change the scripts, right? You're free to do whatever you choose. And in fact, we are looking forward to trying out the new kernel in Rust, which is called Hermit. So we are trying for our U-boot to be able to boot into the Hermit kernel. In fact, I think there's a small Android logo also going around. So we have also tried Android, and we have been able to run Android 13 AOSP on the device. This is just a glimpse of the GUI that we have built in-house. Like I said, this is implemented directly on the GPU. All the rendering happens on the GPU. And compared to using any widget kind of a framework, this uses a Flutter-like design where we are drawing everything on the canvas, and the canvas itself is being directly rendered by the OpenGL rendering on the GPU on top of the compositor. The library is called mctk. It is available. You can go and check out our Mecha.org GitHub organization link for more info, and you can even run examples on your local machine. Also, none of the hardware and none of the softwares that we have built is linked to only Mecha hardware. You are free to use it on any hardware that you like. So even if you have a Pi lying around and if you want to connect it to a display and use our GUI, you're free to do so. Now, if we talk about extensions, some of you may notice the extensions being swapped on the device. So the Comet has 40 pogo pins. Each pogo pin has a digital interface tied to it. These digital interface are power. They can be power pins. They can be ground. They can be I/O, like I/O interfaces such as the I2C, the debug UART, the UART, USB. Right. So those pins are available. And using these pins, you can add capabilities to the hardware, right? So you are not really stuck with a device that is not extendable capabilities-wise. You can extend capabilities. For example, if you want to attach a LTE or a GPS extension, you can use these pogo pins to build extensions such as these. Like I said, these extensions are, again, open CAD files and 3D printable. Some of the extensions that we are going to build, and we have them in our booth as samples. They are the GPIO add-on, which converts these pogo pins into a Raspberry Pi-like 40 pins. We have a gamepad, which could be used for playing emulated games or ROMs. You could just install RetroArch and start playing. If you want to get serious, just swap the game emulator or the controller and replace it with a keyboard and crank up the terminal and start writing SSH commands. So now, in extension to the Comet, we also have other hardware in the family which share the same architecture and the same software and the same kernel. These hardware include the Metal and the Metal module. Metal is our single board computer which brings focus back to embedded computing. We are in contrast to the SBC's industry's focus on bringing desktop-like capabilities to SBCs. We want SBCs to remain SBCs. We want them to be your sidekicks, right? Something that you can play with, something that you can install, custom software, you can try it out, you can use it to deploy your own home server. The Metal has a few tricks up its sleeves compared to the Pi. We have an onboard PCI so that you don't need an extension. We have Coral and NVMe support. You are able to also integrate the same cameras and the same displays that Pi supports, so that also works out of the box. Now, the Metal module is basically, for going a bit lower level, it's a system on module which again shares the same architecture, which can be used for custom OEM applications. Now that we have covered about the hardware part, we'll slowly start talking about how do you really build the applications in the field, right? Like how do you deploy them to the field? So usually the challenges in deploying an application on the field, right? Or you can say on site, it would be authentication authorization. So typically a user authorization happens through passwords or your OTP tokens and stuff like that. But how do you ensure that a device is not spoofed, or when a device communicates to your cloud, it is the same device that you originally provisioned? So authentication is a major challenge. Messaging is also a problem in edge computing, or you can say in hardware deployed on the field, because the net connectivity will not be stable. So if you use something like Kafka on the cloud, you will not be able to take the same and extend it on the edge, right? So you need a solution which is reliable and resilient towards delivering messages and also being able to maintain the order of messages. The other part is in deploying a real world application would be how do you do telemetry and diagnosis? Typically, we are used to instrumentation. We add SDKs, we put something like Sentry or any of the open source, open telemetry kind of SDKs to instrument metrics and logs on our devices. Now, that is also a challenge, right? Like how do you ensure that the telemetry data is collected and the diagnostics are collected and available for you to query, and later you can link it for your alerts or maybe visualize it in Grafana. The other part is secure networking. How do you access the device? How do you configure it? How do you remotely deploy new application to it? What if you could link these edge machines on your GitHub deployment actions, right? You write a deploy actions and it is deployed on all these hardwares. So these are some of the cloud-related problems that we we actually faced during deployment, and we wanted to help Mecha solve these problems apart from the hardware. So one of our core principle has been in building these services is edge is equal to cloud, right? Where we stop seeing edge as a different computing paradigm. We don't see it differently. We see it together as just an extension of a cloud, right? And that has been a primary, you can say, driver for all the architectural decisions that we have taken in building these services. So for messaging, we are using multi-paradigm messaging powered by NATs. I spoke to someone from Zerodha also who also uses NATs in production. So NATs basically is a unified messaging which will let you do publish and subscribe, and it also supports multiple paradigms like queuing, and it also has a abstraction on top of MQTT. So you are able to have resilient messaging. It will ensure that the messages are delivered even if the devices stays offline for a while. If it comes back online, it will ensure that those messages are delivered. Originally, we started with MQTT. A lot of you would have worked with MQTT if you have been in the IoT space. Now, the challenges we had with MQTT was at every point in time, we had to move the message from MQTT to Kafka or any of the messaging queue and then bring it back, right? Now, that is something that we simplified by using NATs overall, and that is something that is abstracted from you who can use our cloud services and deploy software. The authentication for the messaging queue is also linked with hardware, right? So when you generate, like when you provision a new device on our Mecha cloud services, we generate a private key for your device or an X509 certificate, and the private key is securely encrypted within the device. Okay, now if we talk about telemetry, we have open telemetry integrated. We have a metrics logs delivery pipeline. So as soon as you instrument your application that is running on the cloud, you write a script, you write a Node.js script, for example, and you attach OpenTelemetry exporters, right? And so whatever metrics or logs you capture from that application will be delivered automatically to Grafana. The other thing that we have done is networking. When you connect your edge devices to the Mecha cloud and also bring your cloud machines to a Mecha cloud, you can deploy a virtualized networking across all of these machines. We call them machines because we are not differentiating between cloud and edge. These machines will share a private IP address space. The devices are configured with an open source agent that we call Mecha agent, which will do NAT traversal and will ensure that it is able to open up the right ports and the IP addresses, so that from an end user perspective, from a developer perspective, you will be communicating with the edge machines and the cloud machines irrespective of their location, as if they are part of the same physical network. We have also supported bring your own encryption key. So if, let's say, you want us to be not aware of how the signaling is happening and you want full privacy and security over your own network, you can bring your own networking key. And then we are using hardware encrypted storage to ensure that your network key is not known to us as well. Along with that, the last service that we have is called app services. Now, app services is something that we really like. So essentially, a typical cloud application that we deploy or an API that we deploy the API on a server, we push it on a virtual machine or a container, and then we expose it through load balancers. Now, the same thing could be repeated on the edge device. You could deploy a container using GitHub on the device. It runs on a local port, and using our app services, you can expose it to the internet on a target port. So the traffic remains over SSL. I have a small console demo, but I think due to lack of time, I'll quickly skip through. So we'll also talk about the FOSS at Mecha. The Mecha Make is our build tool for building bootloader, kernel, and rootfs for the devices. So everything, they are just set of shell scripts that you can use to build your own images for the hardware. The other one is the Mechanix UI, which is a Valent-based UI shell. We spoke of mctk is the UI framework. Mechanix UI is our UI. The Mecha agent is our cloud connectivity agent. We've also opened up our pilot program. You can reach out to us on our booth. We have a small application form that you can fill up. We will send invites to our private Slack where you can connect for weekly and bi-monthly meetups to discuss on how can we extend the Mecha platform further, and you can actually influence our product decisions and hardware designs. Yeah, anything for Q&A?
Hello.
Yeah, hi.
Yeah. So can you talk a little bit about the pricing of these devices, because I can't find anything on the website.
Okay, so there is a store link on the website. The devices are priced at 16,000. We have opened them for pre-orders and will be delivering by January 2025. The metal is priced at 7,500. Yeah. We also have some exclusive conference gifts if you pre-order during the IndiaFOSS. Yeah. Any other questions?
Hi, can I know about the edge device authorization techniques you are implementing in the open hardware, open source thing? Like you have mentioned something, right?
Yeah. So the agent, the cloud connectivity agent is fully in the open source, and we have integrated open source technologies like NATs, then open telemetry as a standard, as a specification. Some of the other things that we've integrated is Grafana. Our own cloud services right now is still closed source because we are still trying to figure out how to make it open because it uses multiple components. So we are trying to orchestrate that out as well. But eventually we'll be open sourcing our services layer as well.
Okay. Like I was thinking about the spoofing part. Like if you are
Okay.
yeah.
Okay. So I'll give you a simple understanding for that. So the moment you provision your hardware, we send you a provisioning request, or you can say a signature signing token. We give you a signature signing token, which we already have recognized to a machine ID on the cloud. So when the device gets the signing token, you request for an X509 certificate. Now, when you request for an X509 certificate, you will issue a private key on your own device. And that private key can be encrypted in the hardware store. So that will never get out of the device. So because it never goes out of the device, it can never get spoofed.
Yeah, great. Yeah.